Well, folks, welcome to lesson 3-4. So in this lesson, we're going to look specifically at, it's entitled Investing in Yourself, which means we're looking at you purchasing student loans, which is a way for you to purchase knowledge that then translates into hopefully certificates that then get you higher paying jobs. That's the sense of investing. So we're going to make sure you understand the types of student loan options. We're going to calculate interest and monthly payments on this stuff, and then look at what capitalizing interest does. And then we're going to look at when you buy a house, we call that getting a mortgage. Typically, people don't have cash for a house. And so we'll run through that kind of mess. So let's make sure you understand the types of student loans that you're going to encounter. There's these three basic types for undergraduates. You can get federal loans made by the government. You can get federal loans made by banks or other lenders, and then you can get the private loans. You should always go to the federal government first because of the stability and the fixed interest rate and all that stuff. Honestly, you should try to get grants and other free money first, but then when that all runs out, you go to student loans. So let's look at how this is calculated. We're on page 252 of your course pack, and we're going to note this one thing that you need to keep track of for the rest of your thought of student loans. Student loans are simple interest, not compound interest. And that interest accrues only on the principal balance, not on previously accrued interest. So while you're in school, you take out the loan, and then the interest begins to accrue, and it's calculated with the simplified daily interest formula. And we're going to look at that here. So if the principal of a loan is $6,500 and the interest rate is 6.8% annually, how much simple interest will accrue in 1 year? Well, this is a great review of section 3.1. We know that the interest formula for simple interest is I equals P times R times T. From our problem here, our P is $6,500. That's how much we borrowed as a student. Our interest rate here as a decimal is 0.068. And the time here that we're accruing this is we're just going to look at 1 year. So we'll just put T as 1 for now. So that total interest is going to equal $6,500 times 0.068 times 1. Let's look at Desmos and see what is that going to come out to be. 6500 times 0.068. And then we don't need to do the times 1. That means in 1 year, we will be charged $442. So, our textbook author says, why does it make sense to do 365.25 days in a year? And that's because of the leap year. Every fourth year, there's an extra day in February. I think, didn't that happen this year? Y'all correct me if I'm wrong. So we're going to take our interest, and we're going to divide this amount by 365.25 to calculate how much interest are we going to be charged each day. So this is total interest. This is the number of days in the year. And when we divide this in Desmos, we're going to get the amount of interest we're charged per day as we're in school or even out of school either way. So there it is, $1.21 a day is what it's costing. So then we could say, well, how much would accrue in a month? And we're all like, oh yes, there are 28 days in a month, right? Because there's 4 weeks in a month and 7 days in a week, and 4 times 7 is 28. But actually, there are months that are the following lengths. There's a 28-day month. There's a 29-day month, that's the leap year. There's a 30-day month, and there's a 31-day month. So we'll title this month length. So depending upon whichever month we're in, this is the amount of interest that would accrue. So in each of these cases, we need to multiply by 121 for these amount of days, and that's how much interest would accrue in each of those months. So let's do that. I will use Desmos. I'm going to insert not here, I'm going to insert a table. And no, this is dumb. Let's not do that. We'll just do 28 times 1.1. Sorry, 1.21. So that would be $33.88. We'll change that 28 to a 29. $35 cents. We'll change that now to a 30, and it's going to be $36.30. Really, I should just be able to do this in my head, right? 37.51 if I add another day to there, but let's just double check because, oh yeah, I'm on par today. So, depending upon the length of the month, this is how much interest we'd be charged for that month if we use the daily average interest. So here's a simplified formula that you take the principal times the interest rate, divide by 365.25, and then you multiply by the number of days in that month.